I was probably in the middle of a meeting I was delighted to get out of. So, 6 months ago, if you had said, oh, this guy didn't come to a meeting because he had to meet with a benefactor, I would have thought, whoa, where's his priorities? Now I totally understand why he needed to be there. So yeah, this is a mini lecture. I promise we'll wrap it up by 3:45, and folks will have a chance for a break before the 4 o'clock session. So there's no way in the world I'll exhaust all the fascinating things about Georges Lemaître. We heard a lot about him yesterday from Brother Guy. But I do want to approach it from the perspective of what draws all of us here, which is to say what might be some of the particular points of relevance for working with men who are going through seminary training, whether minor seminary or major seminary. And I'd also like to suggest that in a weekend where lots of amazing exchanges have happened and will be happening, for me at least, one of the most important exchanges happened at the end of our morning session when Ed Hogan posed the question to Nancy about soul and mind. Okay, certainly something very rich in our tradition. And Nancy's response was, well, I can only answer that from my own personal perspective. Very honest answer, probably where a lot of us would be. And yet, I would suggest that that exchange, a question about universal truth, soul, mind, body, right alongside a very personal experience, both gets to the richness and the challenge for this whole idea of a faith-science dialogue, interaction that we face as we work with seminarians. Because no practicing scientist would ever submit a paper where their primary justification was, well, this is my experience, right? Think of all the data that Nancy shared with us. She didn't write to Nature and say, well, I was sitting with this gene and it really seems like this to me, so why don't you publish it? And our students sometimes can look at the experience of science, or at least the way they think science is done, and say, well, that's not about faith. You can't have a peer review panel and suddenly decide this is who God is, or these are these qualities of this or that saint. And yet, the fact of the matter is, while there are lots of global things we say about God or about religion, and we would accept them as truths, right? Many of them, most of them reveal truths. The fact of the matter is, all of those things are grounded in a very personal relationship. My own background was working with galaxies when I was an astronomer. And it never once happened that as I spent time with the galaxy wanted to spend time with me. The galaxy never posed a question of me. As I was facing a challenge in my life, I never sat down with that picture of the galaxy. There was wonder there was beauty, there was amazement, all of that. And so for a person of faith, it's not only perfectly fine, but I would suggest it's absolutely necessary that she or he is able to say, this is my personal experience of this God. Now we're gathered here as members, or most of us, of the Roman Catholic Church, so that doesn't mean, and I'm not suggesting, it's just an individual game. What do I think all by myself? The church helps me to understand what my personal experience is. The church helps me to voice and understand the revealed truths that come. But still, at the end of the day, it's a very personal interaction with this God. And if you don't honor both sides of those, then we're never going to be able, I think, to bring our own students, let alone ourselves, more deeply into this dialogue. So while we're talking about Georges Lemaître and, interesting, fascinating man, I just want to hit the pause button every now and then and share what some of my own experience has been using the methodology, or the epistemology, if you like, of the scientific method, how I've brought that into my work. Because I teach scripture, but mostly I was involved in formation. So it's particularly in the area of spiritual direction that I find myself drawing on thinking the way a scientist thinks, while not suggesting that, I get all wonky and use the language of test tubes or something. I was kind of amused where they do the interview room. It says the Spiritual Direction Training Center or something. And one of those rooms is the prickly pear room. And I thought, boy, if some of my former directees could see that. So here's the man himself, early in life and then a little bit later. Just some real basic facts. Born 1894 in Belgium, a little bit northeast of Paris. Went to the grammar school just in his parish school, but Jesuit high school. And he had a desire, sometimes it's said that, gee, it was only his experiences in World War I, and we'll talk about that, that somehow drove him into the priesthood. But no, it's very clear there was a growing desire there for a vocation. But he was faced with a very pragmatic question of whether pursuing a degree in engineering, and for certain financial reasons, he deferred going into seminary studies. But he was very gifted, mathematically particularly, and so initially, he engaged in College of Engineering at Louvain. And then, as for so many people of his generation, was faced with the horrors of the First World War, but willingly enlisted. You see, still a very young man enlists in Belgium's 5th Volunteer Corps. And he's quite decorated as a soldier. He's an infantryman, witnesses actually the first use, belligerent use of chlorine gas. So an experience, he was not himself gassed, but can only imagine the impact that would have. And then does receive a number of quite distinguished medals for his service. So not the usual pedigree necessarily for either a cosmologist or a diocesan priest. But as soon as he demobs and comes out, he goes back to his studies, okay, and pursues a Ph.D. in mathematics at University of Louvain. And the spacing's a little messed up there. But notice what it is. And for those of you, who have a background in mathematics, it's a fairly technical thing, the approximation of real functions and several variables. The point being, this is what I want to stress, he was somebody who had mastered the technical skills that's really required for very advanced theoretical physics. He was gifted for that, to be sure, but he rolled up his sleeves, and there's no shortcut to this. And he sat down, and he just worked through the nitty-gritty using his talents. But I like to think, as we, work with seminarians, there's no shortcut for some of the nitty-gritty, just basic skills that you need if you want to grow in the spiritual life. And I'm not suggesting that there are just simple drills to work through, but I think of modern seminary formation, something like really being able to know yourself well. Is a seminarian willing, say, to avail himself of counseling and not feel like, well, I'm not crazy. Why do I need to do this? At Mundelein, there's still some of a stigma to that. And I'm always saying, take advantage of the opportunity to get to know who you are. We all come from a family. Everyone's family is a mess at some corner or other. We all have life experiences. If you want to live out celibacy, well, what were your previous experiences? Like, all you in formation know this stuff, but there's no substitute for just saying, I want to be attentive to it. And that's not always the most exciting thing. And it's not always going to be what grabs you the most intellectually. But there's a little bit of a parallel there in saying, if you want to do science well, there's no shortcut to being attentive to what's really required at the most basic levels. And it's only because, I would suggest, Lemaître was such a whiz at facilitating, using mathematics, abstract mathematics, that he was able to move into the very abstract realm of general relativity and do it in a way that many of his colleagues weren't, to say, all right, I've mastered these equations, but now I'm going to look at the real world around me and draw actually, realistic conclusions. So he enters major seminary, diocesan seminary, in 1920. So he finished the Ph.D. rather quickly, also with a BA in Thomistic philosophy. And I guess what we're running into here is a PC having to live on a Mac, but I don't know. We'll deal with it. Ordained a diocesan priest, I guess all I need there is in 1923. So a little bit of a late vocation, you might say. Lived through a lot of life experience, but goes through seminary in about 3 years. He'd done a fair amount of philosophy study before that. But then what's rather interesting, especially for the diocesan priests who are here, he's able to jet off to the UK and do further studies. Now, this isn't going to Rome to study theology or something. This is going to Cambridge to work with Arthur Eddington, who was one of the preeminent astronomers and astrophysicists of his day. So somehow he convinced his bishop to let him go and do this. clearly, we should all be happy that that permission was granted. But it was on a Belgian government scholarship. Belgium obviously ravaged by the war, and there were a number of international aid societies offering funds for this kind of thing. But while he's there with Eddington, he works on problems in general relativity, which is still a relatively young, no pun, it's a fairly new field. And he works on, again, for the indoctrinated here, it's not that important, but de Sitter models. And we shouldn't think that this is something that everybody was looking at. I mean, it was a fairly unique thing at this time. Relatively few people had bothered to go into it, largely because it was so abstract and there weren't a whole lot of observable consequences. Probably the most famous consequence was observed by Eddington himself. It was the bending of starlight during one of the solar eclipses. But aside from that, Lemaître didn't just bury himself in the library with his equations. He also used the opportunity that Cambridge afforded him, which is really just to sort of hang out and talk with and educate himself with some of the best astronomers, at least of Europe at the time. And so, astrophysics is kind of what it sounds like. It can be very isolating in a sense from the stars. You're sitting, you're applying physics to stellar, interstellar phenomena. That doesn't necessarily mean you know how to use a telescope. And as Brother Guy, and I don't know if Paul is still here, it's incredibly difficult to use a telescope, especially the kind we're going to be seeing pretty soon. I remember my first time looking at the sky through a little crummy telescope. And everything bounced around. I couldn't see a thing, just as we were hearing yesterday. It's humbling. You look at Saturn, ready to see, the NASA poster. It's this tiny little thing around a tiny little dot. You say, oh, I guess those are the rings. So, again, not going to dig into all this, but just the main point that I would want a seminarian to carry away, as he says, oh, general relativity, well, what's that all about? Well, the about that we should all sort of carry in our back pocket is the very non-intuitive concept that somehow, the stuff that we know and love, mass, energy, density, has a lot to do with the shape, not just of space or of time, but of space-time. And at that point, I think all our common sense experience just sort of goes out the window. But that's a good thing. When I talk with seminarians, every now and then I'll pull something out of the world of physics. I say, look how blithely you guys talk about, homoousios or the Trinity or this or that mystery. And you talk about it as if it's the most obvious thing. Because ever since you were a little kid, right, you've been hearing this language. One of my sisters, says as soon as she taught her daughter to make the sign of the cross, she knew everything there was to know about Christianity. And in some sense, that's true. You spend the rest of your life unpacking that. But so, guys who are very comfortable with language that probably ought to just be blowing them away every time they even remotely think about it, that's not there anymore. A lot of that wonder and awe has been lost. Well, start telling them something like this, or I was talking with Stacy about the beauty of chemistry, and any one of us here could draw on our own professions or backgrounds, and sometimes that's what's needed to bring the humility that probably all of us should have, definitely all of us should have, as we sit down in front of a Christian truth. This isn't about quantum mechanics, but something like quantum entanglement. I ask my seminarians, if I have, two folks separated by a certain distance, what's the shortest amount of time they can communicate? And they all say, well, it's how fast light could travel in that distance. And of course, that's not the case now. I mean, there really is what is seemingly instantaneous transfer of information. And then there are debates about whether you're actually conveying information. I get all of that. The point is, there are things going on right now that are happening in college physics labs that would just, knock the socks off of most people who haven't taken the time to actually learn it. And that's a good thing. When someone is just scratching their head saying, I don't know a thing about this world, I guess. Well, then why do we think the Trinity is something, you passed on your midterm exam? But we do that, and we all fall into that. So it's helpful, I think, just to sometimes use these truths. So just a couple of possibilities that, came out of these early studies. And that's that if you wanted to say that Einstein's field equations were describing the world that we see, And only very slowly were people gaining that confidence. Remember, there was very little experimental evidence in the beginning. But you get some standard, these are the relatively simplest solutions, which is why they were the first. But basically saying, you know, the world, the universe is either static or perhaps it's dynamic, expanding or contracting. Contrary, this kind of goes back to the world is flat thing. Contrary to what you'll often read in the books, well, everybody assumed the world was static, and that's largely true, but there is a long strain, not all of it coming out of theoretical physics, for the idea and the concept that the world, the universe, is a dynamic place. And by that I don't just mean interesting. I don't have time to go into all that, but nevertheless, certainly for Einstein and certainly for a lot of the practicing physicists of the day, the assumption was not that somehow the universe was expanding, which today, right, almost every kid growing up would have heard that language. They'd be comfortable with it. Just because we often hear names and we don't always know what the guys look like. There's de Sitter, the man himself. And there's Alexander Friedman, a Russian, brilliant guy, tragically dies at the age of 25. And so, as is so often the case, you wonder what we might have known otherwise. De Sitter obviously lived into his wise, must be brilliant, as someone was saying, because he has a beard. But while Lemaître is cutting his teeth on these equations, while he's learning about the observational world of astronomy, you know, what's grabbing the astronomical world? Well, this whole idea of what are nebulae. Now, if you look at the top line, you know, any kid would say in a second, those are galaxies. You know, what's the problem? Nebulae are things within galaxies. But I think most people would be shocked to know that it was well into the 1920s before there really was a strong consensus that those things were far, far away from the Milky Way. They were entities like the Milky Way, all unto themselves. That was by no means a done deal in the early part of the 20th century. Interestingly enough, Immanuel Kant, who was really a physicist and an astronomer before he got into some of his other writings that we're more familiar with, but he had this term island universes, you know, and so, but the idea was just, are these things actually very far away, or perhaps are they just within our own galaxy and they're just sort of pretty clusters of stars? This is what people were working on, you know, a little bit earlier than Lemaître came on the scene, but if he were a teenager and asking questions, these would be some of the things people talked about. Now, to thicken the plot, as you looked at these things, you would observe something known as redshifts. And again, we can't go into it all, and people are probably familiar with the idea. But I want to focus on the observation, right? When you say redshift, immediately people's minds are off to the races, and we've got expanding universes, and galaxies are flying away. But what do you actually see? You know, what data are you actually presented with that ultimately leads to that conclusion? And it's stuff like this. I mean, you know, this is a much more modern, prettier, cleaner version. But each of these little spikes, and maybe we'll hear more about this tomorrow, but just think of them as, you know, light that's emitted by certain chemical elements in anything, in any body that's radiating. But for us, it's going to be a star or a galaxy. And the main point is, if you look at the spikes here, okay, the thought is all of those things, as I look at different objects, ought to align, because it ought to be the same thing I'm looking at. But instead, they looked at one object, they looked at another object, they looked at another object, and instead of aligning where you would expect it, you're noticing that they're a little bit offset one from the other, hence the word shift. And they're shifted towards the red end of the spectrum. Okay, the takeaway I want from this is that that behavior in and of itself would suggest a solution, okay? Because normally, quote unquote, redshifts imply motion. So the basic idea being, if, you know, the thing here is emitting waves, or sound waves or light waves, if they're coming towards you, those get contracted a little bit. Shorter wavelengths are bluer. If it's going away from you, the wavelength extends a little bit. Longer wavelengths are red. And so if I'm looking at these galaxies and I'm seeing this kind of shifting to red wavelengths, then seemingly what I have here is motion, or I have velocity, in this case away from me. But notice that that's a conclusion that you're drawing based on something that you observe here on Earth. And then you see something, you know, very far away, And you try and say, well, how do I want to sort this out? Think of what a seminarian is asked to be prepared to do as he goes through his studies. And that's what pastoral ministry is all about. And so it drives me crazy sometimes when, students will either, sniff their nose at what they'll call hardcore theology because they can't wait to get on the streets and do pastoral ministry, or on the other side, yeah, I want to be a priest, I just don't want to have to deal with all those people. Just let me sit here, So the ability to take an experience, right, to like looking at those little spectral lines, and then somehow decide, well, what's going on there? How do I begin to understand what's underlying it? And that's when I said taking the time to know yourself, to do studies in sociology and psychology. Not that that's going to answer everything, but to have a sense of how do you take a very limited data set, okay, talk about the dialogue here, and draw meaningful conclusions out of them. It's a similar kind of methodology and epistemology where any scientist gets that. No scientist would have looked at one of those plots and said, well, obviously, let me tell you what's going on. He'd be laughed out of the room. But sometimes, I'll speak for myself as a priest, and maybe some of you can relate to it, you'll have one encounter or one conversation, and you'll see one thing, and all of a sudden, all these triggers will go off, and oh yeah, I got this one down. And then we're often, with great humility, brought back to reality. But the danger can be there. Well, in the scientific community, if it's handled well, there's a lot of checks and balances on that. So he spends a year in Cambridge, England, likes the name of the town, so he comes over to Harvard the very following year, 1924. Now he's got a scholarship from something called the Committee in Relief of Belgium. So again, you see this attentiveness to the needs of a war-ravaged country. And he takes advantage of that, comes to the Harvard College Observatory, and also takes studies at MIT. Works with Harlow Shapley, very prominent observational astronomer. And in particular, he works on a kind of star called the Cepheid variable. That's very important. I just, for kicks, gave you a little plot. This is the brightness over time. So of one star. They really do vary like that on human timescales. It turns out that is a kind of a magical key for determining relatively accurately how far away those nebulae really are. And so when we say today, oh, galaxy X is so many thousand light years away, that's largely based on this early research on these particular kinds of stars called Cepheid variables. I always thought Harlow Shapley looked a little like Clarence Darrow, but they come out of the same era. The reason this is important is because Lemaître, on the one hand, he's this master of the difficult equations of general relativity, but he's not at all afraid to get down, in the pit and work out the very oftentimes complicated, nitty-gritty kinds of calculations to properly understand and interpret astronomical data that's coming in. And in particular, he worked on determining the periods of Cepheid variable stars and actually made a non-trivial contribution to that particular branch of science. The point is, these Cepheid variable stars are so importantly related to the distance of galaxies, which means they are a key part of the whole cosmological enterprise. And so Lemaître brings, I think, a unique blending of someone who has a mastery of the abstract physics, as well as, if not mastery, he's not the best in the world at it, but a very great familiarity with the practicalities of observational astronomy. And he picks that up very quickly. I mean, there's no doubt the man was a genius. So that's in 1924. And lest we forget, the guy's a diocesan priest. So he's a supply priest at the Harvard parish. St. Paul's. I don't know, what they had him doing, but I'm sure little did they know, right? So second graders were terrorized in their first confession. That'd be a great story, right? My first confession was with the father of the Big Bang. He takes advantage of his time here in the States to go out to some, really key centers of astronomy here on this side of the Atlantic. A little bit north of here, or I guess probably several hundred miles, but Lowell Observatory, Vesto Slipher, or Slifer, I don't know how he says that, an observer out to Mount Wilson in California, where Edwin Hubble, we talk about, this is always the case in our country at least, there's a certain respect for celebrity, and Hubble certainly knew how to, kind of work the press. But to also, we have to give him credit, a very fine astronomer. But he's out there in California, and the results that he's getting are becoming very well publicized. He in particular is the one who's able to tie that research about the Cepheid variable stars to the galaxies they were seen in, and actually determine that these galaxies were so far away. Okay, so I'm showing you this slide because Lemaître visits both of these places. He doesn't spend a lot of time there, but again, he's familiarizing himself with what does the world look like? How important it is for a seminarian. I often tell the guys, you don't know how privileged you are. You've got 4 years or 5 years or 6 years. Every meal is given to you. There's a roof over your head. There's a bed to sleep in. The poorest person in your diocese who put $1 in the collection plate, is putting food on your table as you go for seconds in the cafeteria line. It's an incredible privilege to have all this time to simply be with theology, drink it in, experience pastoral ministry. I mean, this is what it looks like for a scientist, but for our guys to say, I've got this opportunity. Nobody's asking me to go out and, say Mass at 7 parishes this weekend. I don't have to spend 6 hours in the confessional. Take it, I'm preaching to the choir, I know that, but to just talk to these guys as much as possible. Do extra reading. Steep yourself in the spiritual classics. Talk to the people in your parishes and dioceses. You won't get a grade for any of that. What you'll be doing is steeping yourself in what this is all about. So Lemaître puts it all together, and that's the beauty. He does this in about 1925. It doesn't get published till a couple of years later. But when I say he puts it all together, is that he has the galactic distances from the Cepheid variable observations, which he himself has worked on. He's going, along with most people, very reasonable assumption that the galactic redshifts do indicate receding velocities. But now he knows that those velocities are pretty darn high if these galaxies are as far away as they seem to be. And so all of this fits in nicely with his work in general relativity, because he'd worked out a model in which the universe is in fact expanding. And so if that's the case, this kind of redshift, this velocity correlation with distance ought to happen. But because he is a general relativist, he gets something that Hubble didn't get, at least at the beginning. This isn't galaxies flying through space the way we throw a basketball. It's that idea that space-time itself is expanding. And again, at this point, if you're like me, common sense just jumps out the window. And we can talk about it, the equations can support it, but it is not at all the way we experience the world. You're made in the image and likeness of a Trinitarian God. True. What's the next question? That ability to say, I can't take another breath. God is a Trinity. I'm in the image and likeness of that Trinitarian God. Where do you even start to unpack something like that? But, third grade religion class students will be able to state that truth. We all can say space-time is warped by matter. But here, we're comfortable saying, oh my gosh, I'll never understand that. And yet sometimes our students, I'll speak for myself as well, can just say, yeah, I more or less have a handle on this. So Hubble publishes in 1929 in English his famous law. So what you have here is basically distance away from Earth or the sun, and then the velocity. The point being, the farther away these galaxies are, the faster they seem to be receding. It's a creative straight line, but it's a straight line. Probably the research scientists here, wish they could draw a line like that with that few data points. But it's not bad. The point is, in 1927, Lemaître had put everything together. And I want to stress, the graph on the left, he did not make. This is one that was made by a later astronomer, but using his data. What Lemaître did do is he derived what we've come to be called Hubble's law. So he had it all there, and he used that data. He just didn't produce a graph that was so evocative of Hubble's. But you're saying, well, wait a minute, then why do we call it Hubble's law and not Lemaître's law? Well, he published in French in a fairly obscure Belgian journal. And it was just largely unnoticed, not at all an unusual thing in the history of science. Hubble publishes in 1929 in a major English journal, and it just gets a lot more notice and attention. Now, we all ought to be able to say, well, they're all pursuing the same truth. You know, whose law you call it, what's the big deal? But the reality is, we're human, and so people do care about those things. Funding, in this day and age, funding has a lot to do with where the attention goes. But how about in the realm of, you know, pastoral ministry or parish ministry? Sometimes I've shared this story with students, and they, you know, wag their finger a little bit. Oh, come on, what's with these guys? Why can't they just appreciate the truth for what it is? But you don't have to try too hard to, you know, look into any diocese to begin to see how personalities and egos and whatnot can begin to play a role, or even in the history of theology. So it can just be humbling a little bit sometimes to see, because this got a little bit ugly, the whole question of where you place. Even though Lemaître is often called the father of the Big Bang, it's important to remember that for him, there really was no Big Bang. And what I mean by that is, initially, he was as comfortable as Einstein was with a relatively static universe. The idea that the expansion would come was the result, and again, we can't get into it, and I certainly couldn't just rattle it off, that there's an instability in that initial state which ultimately leads to an expansion. But for him, the initial go-round, what he was worried about was accounting for the observations that he had. And so his initial state was not some super tight thing that we tend to associate with that singular state which then, you know, explodes, or however you want to call it. Initially, he was okay with what he had because he was trying to account for certain observations, and I think for him you always see that in his work. What is it that's observed that I'm trying to explain? The problem, however, is that the time frames involved with his model were not adequate to support the observed universe. What that means is, using the model that he had, he would not have been able to account for the amount of time we knew was necessary, or was growing to be known as necessary, to form things like stars and galaxies. So I realize I'm just slapping it up there and, you know, asking you to nod your head or to question. But my point is, he was always letting the observations drive him. And so initially he had a model that could account rather nicely for what was seen, but then eventually what was seen stretched that model beyond credulity. And so then he begins to say, well, you know, where is this leading us? He comes up with a second model, which, you know, he calls the primeval atom, which indeed is what probably most of us would be familiar with, the idea that initially the universe is incredibly compact. But what I want to stress is, it's not that he initially saw the expanding universe in his first go-around and said, well, if we run the camera back, then it all must go back to a point. No, his equations did not require that, and that's not where his mind was going. It was only when he was trying to solve the problem of, how can I make this universe be robust enough to account for the stellar physics and dynamics that we've subsequently known about, and then things start leading him, again, using the same kinds of equations, to a model that indeed does have to begin. So what you're seeing here is time, and then, if you like, radius or size of the universe. And so in the beginning, everything going back to, you know, some very condensed point. His model is fascinating because it expands, and then it kind of plateaus for a while, and then it expands again. And some of you might recognize that as roughly the dynamics of inflationary cosmology. In very different timescales, very different physics. But this idea that you could have an expanding universe that then kind of pauses for a while, and that's really where a lot of the star and galaxy formation happens, and then it begins expanding again. I say for him that wasn't a bang because he called it the primeval atom, and that was really his idea. So for the chemists here, his thought was that you had some sort of superatom with an atomic number of, 10 bajillion, and that what happened is it just went through a sort of normal radioactive decay into subsequent matter. But it was not a sort of violent explosion or a violent tearing apart. It was kind of a very gentle process. Now, quantum mechanics, wasn't nearly at a point where he could really do a lot with that. It was just more kind of a speculation. But you can go back. This paper was published in English. It was translated in 1931. I'll be happy to give that reference to anyone. But Lemaître and the papacy. So, by this point, just because he was able to handle the whole expanding galaxy or receding galaxy problem, he gained a fair amount of respect in the scientific community. So Lemaître and the papacy, he's appointed as one of the founding members of the Pontifical Academy of Sciences in 1936 by Pius XI. He's named the president of that shortly before his death by John the 23rd. And he himself was highly amused that in 1960 he was put on the Pontifical Commission for Birth Control. Not that he thought that was an amusing thing, but that wasn't his background. But he was an eminent, a very eminent cleric and scientist. But it's, as we heard yesterday, his relationship with Pius XII that is maybe particularly noteworthy. Because Pius XII did have a fairly advanced knowledge in science, at least up through his secondary school education, knew a fair amount about astronomy, among other things. And so Brother Guy reminded us, he said, look, Pius XII gave this sort of baptism to Lemaître's work. Well, here's the actual statement, or part of it. In his, an address to the Pontifical Academy of Sciences, and Lemaître did not know that this was coming. But basically, what was the nature and condition of the first matter of the universe, Pius asks. Indeed, it would seem that present-day science, and this is right on the heels of work on the expanding universe, with one sweep back across the centuries has succeeded in bearing witness to the august instant of the fiat lux, when, along with matter, there burst forth from nothing a sea of light and radiation, and the elements split and churned and formed into millions of galaxies. Okay, so as was pointed out yesterday, this was never the sort of way Lemaître presented his results or his findings. He was always drawing that distinction between creation and beginning, or creation and origin. You can use whatever semantics you want. But that the physics itself is telling you about the initial conditions, if you like. It's not talking about, why is there something rather than nothing. Well, look at the dates. November 22nd, 51, Pius XII makes a statement. The cover of Time magazine on December 3rd, 1951, is Behind Every Door, God. Fascinating thing. You can go online and see all the covers of Time magazine back to the first one. Go to 1951. The one cover that's not there is this one. There's got to be a conspiracy behind it. But I was all set to get you a great graphic, and there it is. Cover not available. It's only this one. But in the article, here's what they say. Is there, as many scientists assist, an unbridgeable gulf between modern science and revealed religion? Right? So if we think we're on the cutting edge here, this question has been around for a long time. In the latest Physics and Astronomy, says Pope Pius XII, true science discovers God in an ever-increasing degree, as though God were waiting behind every door. In particular, he told the Pontifical Academy of Sciences, the proofs of God's existence, which St. Thomas Aquinas advanced in the 13th century, are constantly being buttressed anew by the discoveries of science. Just in the last minutes, I want to share with you some of Lemaître's statements himself. So that was 1951. Right in the wake of his most famous work on cosmology, in the 30s, he wrote a very famous one-page letter to Nature, right, which is kind of the preeminent all-science journal. Okay, they don't just specify to biology or physics. So it's kind of a place you'll often use if you really want to make a statement to the world. At least it certainly was in the 30s. And so he has it's literally just 2 paragraphs, very readable, where he lays out, here's the punchline of my research. And so this is all a direct quote. In atomic processes, the notions of space and time are no more than statistical notions. They fade out when applied to individual phenomena. What he's getting at here is if the whole universe, has contracted to some sort of primeval atom, that in a quantum sense, you have to use quantum physics to describe what's going on there. And there's an indeterminacy in that physics, which basically says it's meaningless to talk about time in the sense of 1, 2, 3, 4, and it's meaningless to talk about space in the sense of, well, lay down your ruler and this is 2 or 3 inches. So it's not that we're before time, but it's that we have an initial condition such that time and space as we know it, haven't, quote, been created or haven't yet come into play. So it's logically prior, but it's not temporally prior. And so he says, applied to this individual phenomenon, if the world is begun with a single quantum, the notion of space and time would fail to have any meaning at the beginning. You can't get away from using words like beginning. They would only begin to have a sensible meaning when the original quantum, his initial primeval atom, as he thought of it, which is not the way we think of it today. So don't think that Lemaître perfectly described inflationary cosmology. But that idea, he says, if this suggestion is correct, the beginning of the world happened a little before the beginning of space and time. So take it out of context, and that's gibberish. You see what I'm getting at? He's recognizing there's a need to marry the general relativity with the quantum mechanics. So he's very prescient in that sense. He doesn't have the ability to do it. But he's saying, look, somehow we're in a realm where time as we normally think about it and space as we normally think about it is not really applicable. I love this line. Arthur Eddington, his friend, remember his former mentor, was thinking about this idea that the universe began in a very small, compact state. And he said, he used the word repugnant. And so Lemaître, being a good student, immediately responds. Sir Arthur Eddington states that philosophically, the notion of a beginning of the present order of nature is repugnant to him. It just doesn't make sense. You see that sense of the culture, right? No, it couldn't be that way because we all know it's some other way. Really? Are you 10 billion years old? But it's just there, and we have that sense. Okay? I would rather be inclined to think that the present state of quantum theory suggests a beginning of the world very different from the present order of nature. I think that such a beginning of the world is far enough from the present order of nature to be not at all repugnant. That's a very roundabout way of saying it, but I love that line. And that's why I said when everything is strange, nothing is strange. In other words, we're in a realm here, in this quantum realm, that's so counterintuitive that for you to say, oh, that's distasteful, it's like that word doesn't even apply because your standard of taste doesn't even have a leg to stand on in this. And I read that every time I read it, I think about theology. As we sit with this or that theological claim or truth and say, well, that just doesn't quite square with what I have. To realize, well, do you even have the right to say that this doesn't square with what you have, or this doesn't make sense, or this doesn't seem reasonable, or that couldn't be what God is up to? And we're always reminded, as we have been many times this weekend, in the face of God we know nothing, there's nothing we can adequately say, and yet our seminarians are going to go out there. They're going to have to say and listen to lots of things. And so that ability, that humility to be able to say, okay, I've got something here, and just like I look at a galaxy, which is very large, and time and space as I know it is very relevant, but can I believe and begin that if I dive deeper and deeper and deeper, that really is plugging me into that mystery at some level? So that what I maybe think is strange or repugnant almost isn't even an applicable or fair adjective. And I would suggest that that's what happens every time a parish priest, has that chat with somebody on the way out from Mass. We don't realize it, but if we just stopped and really let it sink in for a little bit, here I am in relationship with the image and likeness of a Trinitarian God, who, by the way, is love. Physics has its axioms. The speed of light, is constant. The value of the speed of light is this. Christianity has its axioms. God is love. Nobody proved that. God is a Trinity. There's your axiom. We are in the image and likeness of that God. There is an axiom. Nancy beautifully said, I've got these pieces. I've got a gene that sort of works this way. I've got a fly that behaves that way. I've got an eye that has these qualities. What if I put this in here? What's going to happen? If this is true, then what's the consequence? Every time, I used to be a campus chaplain, right? Kids come in and I don't believe in God. Oh, where's God? This is all nonsense. Well, as a Christian, you can always start by saying, what's your experience of love? Fine, you don't believe in God? Well, I'm not so sure myself, but tell me about love. Well, either they know it or they don't know it. But boy, every college student is thinking about that. Or their heart has been broken. If you're a Christian, that is at least a threshold into the dialogue. And we are so rich for having those axioms. That we're in the image and likeness of a Trinitarian God, then none of us can escape from relationship. And yes, an atheist can always say, no, you're just talking about the human condition. You're just talking about, we're a relation. That's fine. I don't lose any sleep over the fact that atheists don't agree with me. I think the richest part of the faith-science dialogue is what it has to contribute to the way people who already have faith can deepen and dive into and hone and just be held in ever deeper awe about what those sometimes can be very glib statements about the truths of our faith are. It's always time. I know people need a break, and 4 is our next thing. So,
Finish.
Well, no, I mean people have statements. Particularly since everybody here works in formation at some level, right? If you teach, I always say to my academic faculty, don't think for a minute you're not in formation, because the students spend way more time with you than they do with their spiritual directors. So from the formators here, any statements?
Are you ending?
Yeah, I mean that's it.